Myself, Anirban Mitra, Mechanical Engineering Department, MES College of Engineering, Vadaya College Campus, Pune. Today I just want to explain you the graphical methodology to find out the principal stresses, maximum shear stresses or normal stress, tangential stress along the plane. Basically, I am concentrating on how to solve the numerical using the Mohr circle. So first we take one problem. This is a one element. Along that x direction, sigma x is applied 100 Newton per mm square. It's a positive as it is in tensile force outward from the body. Sigma y along y directions is again plus 50 Newton per mm square tensile. Then along the x plane is actually perpendicular to the x axis. So perpendicular to the sigma x, that is called the x plane, and that is denoted by the tau xy. And the sign convention of the tau xy, if on the x plane, if it is rotating in anti-clockwise directions, then it will taken as in positive. If it is in clockwise directions, then it is taken as in negative value. As they are given that value as 50 Newton per mm square positive, so we are taking it as an upward direction. Similarly, along that y plane, so this is the y plane perpendicular to the y axis, its default negative. If that x plane is positive, then y plane must be default negative value. In the question they asked you to find out the principal stresses and its orientations, maximum shear stresses and its orientations, normal and tangential stresses on a plane at an 60 degree with a plane of sigma x. So what is the meaning of plane of sigma x? With this is called the plane of vertical plane is called the plane of sigma x. So with this sigma x, it makes the 60 degree angle, and we have to find out the normal and tangential with the 60 degree angle. So one by one I just explain you the step to solve the Mohr circle. First thing, it's a very important step to find out the coordinate of x and y. X coordinate is always sigma x and tau xy. That is the stresses, on the x axis and corresponding plane the value of the tau, that is called the sigma x and tau xy. So as per this problem is concerned, it is coming positive. Positive negative is a very important. That's why I'm explaining you tensile is positive, compression is negative. Along x plane, if it is an anti-clockwise direction, is called positive. Along y plane, it is in clockwise direction, is called the negative sign. So if this is a positive value, then we know that x coordinate is the sigma x and tau xy plus 50 plus sigma x is a plus 100 and sigma y x tau xy is equal to 50 mm is equal to 50 Newton per mm square. Okay. Similarly, that y coordinate is equal to sigma y and tau yx. So sigma y value is given that positive 50 here, and tau yx is given negative 50. So first we have to draw the coordinate system, that is called the O plane or x axis and y axis. One thing is very important to solve that principal stresses is the sign conventions along x axis and y axis. So according to the coordinate system, along x axis we are plotting the sigma value, that is called the normal stresses value. Along y axis we are plotting the shear stresses value. So I just explain you that what directions, positive negative, you should take it to match the value with the analytical solutions. Okay. So this is plus sigma, this is minus sigma along x axis. Similarly, y axis is my tau value, but only thing you have to remember to match with your analytical value is the direction of tau is opposite. So upward is normally we are taking positive, but here in the Mohr circle we are taking the negative tau, and downward we are taking the positive tau. So that is a very important step to remember only. Once you just assumed this is the direction, then your all values of sigma 1, sigma 2 are matched with your analytical solutions. Okay, so first we plot that to axis OX and OY, and considering that positive and negative directions of the sigma as well as the tau. Second step, scale. So here they are given that 100 Newton per mm square and 50 Newton per square. So we are assuming that 1 centimeter equal to 10 Newton per mm square. This is the sign convention we are assuming. Already I explained you that right side directions we are considering it as in positive, left side directions considering is a negative, that is called sigma value along x-axis. Tau downward is positive, tau upward is negative, that is opposite to the normal conventions. Angle measurement anti-clockwise is coming positive and clockwise coming negative. So first I want to plot that y coordinate. You can see that what is that y coordinate, that is sigma y and tau xy. What is that? Plus 50 and minus 50. So I have to mark that plus 50 as my scale is 10 Newton per mm square. So 50 divided by 10 it will be 5 centimeters. So from O I measure 5 centimeter, that is sigma y. Then I measure the tau xy, tau yx, so that is another coordinate minus 50. You know there is an only chances of the mistake. Negative tau we are taking in upward direction. So minus 50 is coming on the upward direction. So then the intersection of this point is called the y, which is sigma y and tau yx. Similarly, we plot that x point. So this is the y point. I just take it as an y point. Then I have to plot the x point. So sigma x, again 100 Newton per meter square means 10 centimeter. Then tau xy is in positive 50 centimeter, 50 Newton per mm square. So if we convert it to divided by the scale, it will be 5 centimeter, but it's in positive, that's why it is in downward direction. That thing only you have to remember. So I mark the point sigma x, coordinate of sigma x and tau xy. Then this is the if you draw the vertical line from this x point, so you are getting that a point here, and from y point if you draw the vertical line you get the b point. So remember, my suggestion is if you are using the same notation to solve the principal stresses, I think it will be very easy to solve any problem using this methodology. So now we are getting that point x and point y, that is from the coordinate x coordinate and the y coordinate, and according to the sign conventions positive negative. Next step is join xy line. Okay, then after joining xy line, where it intersects the x-axis, mark that point as in C. This is the center of the Mohr circle. Okay, and the radius of the Mohr circle is that Cx or Cy. Both are the radius. So what is the center? Center is the intersection of xy line and that ox line is the C, and radius is the Cx or Cy. So I just take as a center and draw that one circle with the radius of Cx. Okay, now we have to find out, now we completed the given data, that is they are given the sigma x, tau xy, sigma y, tau yx, and we are finding out that center. We have drawn that one more circle. Now we have to find out that whatever they have asked to determine, one is the principal stresses and its orientation, maximum shear stresses and its orientations, normal and tangential stresses on a plane at an angle 60 degree with the plane of that sigma x. So one by one I just explain you. The first thing I just want to find out the principal stresses and its orientations. So after drawing this circle, wherever it intersects the x-axis, mark that point as in P1, and O to P1 distance is actually my major principal stresses sigma 1, major or maximum principal stresses sigma 1. Okay, similarly that circle cuts that another point of that x-axis, mark that point as in P2, and distance between O to P2 is my minor principal stresses sigma 2. Remember, sigma 1 is always called the major one and sigma 2 is always called the minor one. So O, from O, wherever is the maximum point lies, mark that point as in P1. It's not that always right side or left side. Maximum point should be marked as in P1, minimum point should be marked as in P2. I suggest you earlier also use same notation to solve that Mohr circle easily. So OP1 is my sigma 1, OP2 my sigma 1. Later on I just explain you how to find out the values of sigma 1 and sigma 2. So I think the one step is over. We are already found out the principal stresses. Now the second part of the principal stresses is its orientations. Orientation means angle. Okay, so for that angle you just remember one thing, this Cx or xy line is representing our normal horizontal axis. that is called that horizontal plane or x plane, right? Okay, and this CP1 or P1 P2 line is actually representing our principal plane. So to find out the orientations, always you have to measure the angle between the horizontal line CX with the principal plane CP1. So this is called that x axis, and this one is the principal axis CP1. So angle between XCP1 is actually the orientations of the principal stresses. So you just see it, this is that angle is the double of the normal angle given in the problem. So that is called 2 theta n1. One thing you have to just remember, here I have written it as a positive. Why positive? I already explained you. Anti-clockwise direction is called positive, and negative angle measurement is called the clockwise measurement is called the negative direction. So here I have to put the protector on this line, and from this line it will measure in anti-clockwise direction. That is coming a positive 2 theta n1. Similarly, the theta n2 value is the theta n1 plus it is a 90-degree angle only. Okay, so remember, in the Mohr circle always we are getting double value. Okay, and then you have to half it. Okay, so that is called the plus 2 theta n1 value is the principal place orientation. So now the first question is over. We got that major principal stresses sigma 1, we got the minor principal stresses sigma 2, and we got that its orientations 2 theta 1 also. As it is an anti-clockwise, it is coming positive. Now go to the second part of that question, maximum shear stress and its orientations of the plane. So to find out the maximum shear stresses, we mark that two vertical plane, one is called the S1 and other one is called the S2. Remember, normally you mark that S1 in the coordinate where the x lies, in the coordinate where the x lies. So x is lying here in the fourth coordinate, that's why I marked this point as an S1, and the other point is called the S2. Okay, then our x plane or our x direction is the CX line, and this CS1 basically is your tau max value. So that is called that maximum value, and this CS1 is actually our maximum shear plane. Okay, so CS1 is the maximum shear plane. To find out the orientations, again we have to measure with what? We have to measure with the x axis CX. So the angle between XCS1 is basically our 2 theta S1 value. Just see, okay, that is in 2 theta S1 value. Now just see here I have mentioned the negative value. Here it will be positive, here it will be negative value. Why negative? We have measured it with this line in clockwise direction. So clockwise angle we have measured it in negative value. So if you use this or this sign conventions only, then your all answer to be matched with the analytical one. Okay, I have referred that with the book Some Strength Material by the Timoshenko, or it is in Popov also, Igor and Popov. So from this book I am finding out the directions, and I also solved all this problem in analytically. So it is exactly matched with the sign conventions. Okay, so that value is called the 2 theta S1 value. So I got that second one also. Now the third one, normal tangential stresses on a plane at an angle 60 degree with a plane of x, that is of sigma x. So here we know the sigma x, plane of sigma x. What is the meaning of plane of sigma x? This is the sigma x, and this is called the plane of sigma x. Earlier also, okay, I explain you our x directions or our plane of sigma x is always the CX line. This is called the plane of sigma x, right? Okay, as it is in x point. So we have to measure every angle with the plane of sigma x. So here also 60 degree angle we have to measure with this. In the problem, whatever angle is given, in the Mohr circle it is double it. Okay, or in the Mohr circle whatever angle we are finding out, in the normal problem it's a half of that one. So as they are given the theta value is equal to 60 degree, so when I just mark that 60 degree in the Mohr circle, I have to double that. So it will be 60 into 2, 120 degree. From what to measure? From the x plane, that is CX line. As again it will be positive value, I have to measure it anti-clockwise direction only. I have to measure it anti-clockwise direction only. So I put my protector on this line and measure the 120 degree angle with the CX value. So just check it here. It will be 120 degree 2 theta value. I just join one line with this. Wherever it intersects the circle, mark that point as an N. Okay. From this N, draw a vertical line. Wherever this vertical line cuts that x-axis, that is called the M point. So this line is NM line. Okay. Similarly, we have to also find out the resultant stresses. To find out resultant stresses, we have to join ON line. ON line. Okay. So I think I repeat that step. Okay. So first you have to mark what? First you have to mark that angle measured from CX line. As it is in positive, it will be anti-clockwise. If it is a negative value they are given, we have to measure it in clockwise direction. So 120 degree, marked it, draw a line wherever it intersects circle N, draw a vertical line wherever intersect it x-axis M. To find out the resultant stresses, join ON. Now NM is my tangential at 60 degree angle. Similarly, OM is my normal at 60 degree angle, and ON is the resultant of sigma N and sigma T. Okay. Also, one thing we have to find out in this case is that is called the obliquity angle. So obliquity angle is a measurement. It is an angle between MON. So you can see it will be MON, and that angle is called the phi angle. This is the only one angle which is not double in Mohr circle. Whatever angle is measured from the C, that will be double, but this one is not double. So that is called that phi angle in this cases. Okay. Now I just see you that how to get that all answers, okay, all the values of principal stresses, maximum shear stresses. So here, this is a very important. I think if you can remember this notation, it will be very easy to solve our next problem. Sigma x. What is the sigma x? That is the distance from O to A. Am I right? Okay. What is the tau xy? It is the distance between A to X. So all the time use the same notation. Sigma y. Sigma y is the distance between O to B. I think you can get it here. It will be sigma y. And tau yx is equal to B to y. So this is a tau yx. Okay. Theta angle is also given. So theta is the angle between xc and xcn, that is given 60. So in the Mohr circle we have to double it. So that's a given data about it. What we have to find out in this case is the principal stresses. So these are the notation you remember, and for the next further problem we are using the same notation, and then it will be very easy to solve the problem. So what is that sigma 1? Sigma 1 is basically distance from O. O is the origin point, O to P1. So OP1 always denoted for the sigma 1, and if you measure through scale, then it will come in the 13 centimeter. Similarly, sigma 2 is that O to P2. So OP2 is sigma 2. So that is also 1.9 centimeter multiplied by the scale is your actual value in Newton per mm square. Theta n1 is the distance, or is the angle, actually sorry, it's an angle between xcp1. Cx is your x plane and cp1 is your principal plane, already explained. So xcp1 is your 2 theta n1 divided by 2 is that actually theta n1 angle. Theta n1 is actually representing the angle of sigma 1, and if you want to find out the angle of sigma 2 or orientation of sigma 2, so theta n1 plus 90 degree is the orientations of what the sigma 2, that is also denoted by the theta n2. Then the tau max is cs1. Okay. It will be measured at 5.6. X theta s1 is that angle again with the x plane. Xc is the x plane, so xc S1, CS1 is the shear plane, maximum shear plane, XC is that XY plane. So XCS1 is that orientations of maximum shear plane, or XCP1 is that angle of major principal plane. Okay. Sigma n is O to M. So here it will written sigma n is O to M. Sigma t is NM. Sigma t is equal to NM. Okay. Now remember here, it's a very important thing actually. The OM is a measure 10.6 centimeter. Okay, so you have to multiply by the 10. But NM I have written here minus 4.7. So can you please tell me why it will be negative value? Okay, I think already we explained it. The tau is along y-axis and the sign convention of tau is exactly opposite to the conventional one. So upward direction is a negative value, and here the sigma t is an above x-axis on the upward direction. That's why it is coming a negative of 4.7 centimeter. and if you multiply by the 10, it will going minus 47 Newton per mm square. If you also calculate with your analytical formula, you are getting the negative value. Okay, so that's why that this sign convention you have to refer it. Sigma r is basically under root of sigma n square plus sigma t square. Here in the graphical it will be on. So if you measure on, it will coming 11.6 centimeter, and phi is also angle between the m o and n. So MON is angle is called the phi. This angle is not the half of that angle. Okay, so any angle measured with C should be the half angle, and angle measured with O is your obliquity angle, and that angle is measured at 24 degree only. So these are the notation you remember. Okay, okay. Now I just give you that all stresses value after multiplying with that scale factor 10 Newton per mm square. So 13, so sigma 1 is coming 130, sigma 2 is coming 1.9, so it is also coming 119 Newton per mm square. Theta n1 is coming positive value, positive as it is in anti-clockwise, so it will be 31.25 degree. Then the tau max is again the 56. Now here remember the tau max is always in analytical formula also it is coming plus minus. Why plus minus? Because this CS1 is our positive value, CS2 is your negative value. So it is always coming in the same value and it will be positive negative. But the theta S1 is corresponding to the CS1, and CS1 is in clockwise, that's why it's coming negative 13.8. And if you want to find out theta S2, so theta S1 plus 90 degrees is the theta S2 value. And also I think you know that the angle between the principal plane and the shear plane is always a 90 degree. So if you just add this 31.25 and this value, so it is coming the 90 degree angle only. So this is that one set of answer. The other third questions they ask it to find out the sigma n sigma t. So I think the sigma n is the distance between the O to M. So O to M distance is 10.6. It is also positive as it is on the right hand side of the y axis. So 106 10.6 into 10. The sigma t is coming negative. I already explained you 4.7 negative value multiplied by 10, 47 Newton per mm square. Sigma r is a 116 Newton per mm square, and phi is the obliquity angle. That angle you have to measure with respect to the O, that will be 24. This is not the half angle. So finally this is the answer. You can get it using the Mohr circle. Now this is a very important concept. I just want to explain you one thing. If this Mohr circle you have to convert it to your element diagram, okay, in your element diagram, then how it looks like and what is the meaning of the theta n and theta s1 and all this thing. So please refer it. Okay, so in the next slide you can get it on this. So this is my element, okay, where element center I assume C means this is the point C. Okay, so here in this x-axis we are getting that x plane, that is called the x plane. Now you just checked it one thing, that every time I told you the CX is our horizontal plane or horizontal line or the x plane. So here the horizontal line is CX. Actually we have to turn this CX line, make it horizontal. Once it will make it horizontal, your CP1 is turning in anti-clockwise direction with the value of 2 theta n, not with 2 theta n. It should be half in your element diagram, so it should be theta n value, but it will be on the anti-clockwise directions. Measure it from that one. So we do the same thing, only rotate the CX in an horizontal manner. Okay, so just checked after this. So I think this is that one element we are considering 1 2, and this line is called the CX line. Now in this element, if you want to find out the maximum shear plane or the major shear plane and the minor shear plane, so then how to find out? So I already know the major shear stresses sigma 1 is equal to plus 130 means tensile nature, sigma 2 is also plus 19 Newton per square tensile nature, and the value of the theta n was equal to 31.25 degree, and that one is also positive. Now we have to measure this distance angle from CX in anti-clockwise direction as it is in positive. So just see this. So here it will coming the theta n1 positive means anti-clockwise directions, and then this is that element. This plane is called the principal plane, named as in CP1. So I am just representing with your Mohr circle CP1. So this is the CP1 angle, and on the CP1 whatever is that stresses, major principal stresses is applied, that is called the major sigma 1, and perpendicular to that one is called the sigma 2. So this is this plane, CP1 plane is called the principal plane. So here in this plane the maximum stresses is produced, and on this one is again maximum, it's with the 90-degree angle only. So then if I want to find out the maximum shear plane in this element diagram, so I think the maximum shear plane with the theta S1, but remember it is in clockwise directions with respect to the CX line. So with respect to CX line, here it will be clockwise, that's coming the negative value. And if I draw that element, turn that element, so I am getting the same element, 1 2 element here also in that shear plane. So in this 1 2 element, the value is coming tau max, and every plane it must be same, but it will be just opposite to each other, and this plane is called the maximum shear plane. So if you see one element here where this is x plane, where the sigma x, sigma y and all tau is applied in this case, I think this is the element I am just drawn it here, and if this element is turned with the theta n1 value, then that is called the maximum principal plane. If it doesn't turn in negative theta s1 value, then we are getting the maximum shear plane. So that's the overall concept of the principal stresses and how to solve it in the Mohr circle. And again, if I convert it from the Mohr circle to that element diagram, we can understand that element diagram in this way. Okay, now this is the normal problem. You have to solve it. After that, we have to just do one thing. We have to solve that 2-3 problems more to understand the various type of problem asked normally in any competitive exam or your university exam on that Mohr circle.